In the final part of this lecture, I want to continue on this theme of governments managing the macroeconomy and using this basic Keynesian model as a way of thinking about how that might happen. We've looked at fiscal policy, and we've seen how in the logic of the model it's possible, for example, that changes in government expenditure might be a means of managing the macroeconomy, of correcting a contractionary output gap, for example. Then we also discussed some of the difficulties with doing that. There is another type of macroeconomic policy that is used quite extensively, in fact used more often than fiscal policy in this regard, and that's monetary policy. We're going to talk lots more about monetary policy in later lectures, but I just want to show you how monetary policy fits into this basic Keynesian framework and give you a bit of an insight as to why during the global financial crisis, for example, it wasn't just fiscal policy or government spending that was used. Monetary policy was also an important component of government's response to the crisis. So let's take as our starting point an economy that's in a contractionary output gap. And we now understand that an economy in this sort of equilibrium, there is perhaps a role for government to play in trying to encourage or to stimulate or to directly bring about an increase in planned aggregate expenditure so that we can move to a situation where the economy's equilibrium corresponds to potential GDP. So that's the aim of government management of the macroeconomy, at least in this context. Now, how can monetary policy assist this process? What is monetary policy, first of all? It's actually a bit difficult to pin down an exact definition of monetary policy because different countries implement different types of monetary policy depending on their financial systems. But broadly speaking, when we speak of monetary policy, we're talking about the central bank intervening in the economy, in particular intervening in financial markets in particular ways that influence either the rate of interest that exists in the economy or perhaps the availability of credit. And sometimes those two things are used simultaneously. Sometimes the emphasis is on one, sometimes the emphasis is on the other. I'm going to focus mostly on the influencing of rates of interest. I think that's a little easier to explain. It shouldn't be too hard to go from what I'm saying towards situations such as in the United States, where they implement now what is known as quantitative easing, which is very much direct action to try to influence the availability of credit. But I'm going to focus on the more general case and the policies that are more widely used, and that is central bank interventions to influence rates of interest. I'm not going to talk so much about how central banks can influence rates of interest. We'll actually touch a bit on that in a later lecture. For the purposes of this lecture, let's just take it as granted that central banks can do exactly that central banks have within it the means or mechanisms to influence rates of interest generally in the economy. Why might they do that? It's because there are components of planned aggregate expenditure that are almost certainly quite sensitive to rates of interest. Think of household, for example, household consumption. In our consumption function, we very much focused on disposable income as being a very significant determinant of household spending decisions. But interest rates could be important as well. Think about your own behaviour and your own willingness to use a credit card, for example, to finance expenditure. Well, the interest that is levied on that credit card might have a role to play in your willingness to use that card for the purposes of expenditure. But it seems for many economies, the most interest-sensitive component of planned aggregate expenditure is investment, planned investment, and that's what we are going to focus on, the link between interest rates and investment. We've spoken a little bit about this before, so let me just formalise why interest rates might be so important. It gets back to the nature of investment and how the benefits of investment are only received after some time has elapsed. So think of time being measured as we head from the left-hand side of the screen to the right-hand side of the screen. Think of an investment decision that takes place today, purchasing and installing a piece of capital equipment. It's unlikely that that equipment is going to produce output today. Maybe it's only 1 month later that the capital equipment finally produces some output. And maybe it's 3 months later that that output is eventually sold. So the benefit from that investment is, at least in this framework, 3 months into the future. This creates for the firm a cash flow problem. What do I mean by that? Well, cash has to be paid up front for the purchase of the equipment. But cash is only going to be earned at some time in the future. So it's not too surprising when you think about it in these terms that a great deal of investment expenditure is financed through the borrowing of funds, which means the cost of that borrowing, the interest rate, is going to be a significant factor in influencing firms' decisions about whether or not the purchase of a piece of capital equipment, the act of investment in the other words, whether that is a profitable course of action. What that means is we expect that planned injections in the economy, in particular the planned investment component of that, is most likely to be very sensitive to the rate of interest. You might, for example, have an interest rate of 5%. At an interest rate of 5%, planned injections through planned investment are as shown on this slide. If monetary policy actions are taken which reduce the interest rate from 5% to 2%, then that might encourage firms to increase their planned investment. It's cheaper to get those borrowed funds that are needed to finance the investment. We might therefore see a systematic increase in planned investment and hence in planned injections. So that's the sense in which monetary policy has a role to play in the basic Keynesian framework. It can impact on interest-sensitive components of planned aggregate expenditure, in particular on planned investment. A quick note on interest rates. They're a very complex part of the financial system, and I just want to make sure that we're on the same page and we understand what we're talking about. Let's take a very trivial example with two individuals, Jill lending $100 to Jack, and Jack promising to repay that loan after 1 year with an additional $5. There will be what's called a nominal interest rate associated with this particular loan, and I'm going to use some notation here. When I speak of the nominal interest rate, I'm going to use capital R to indicate that interest rate. Nominal interest rate is sometimes known as the market interest rate. It's the interest rate that's quoted to you when you go into a bank and apply for a loan, or it's the interest rate associated with this Jack and Jill loan that we're talking about here. In this case, the interest rate relates to the $5 payment when the loan is repaid. What is that relative to the size of the loan? $100. The nominal interest rate in this case would be 5%. Often we write that as just 0.05. What the nominal interest rate is the interest rate that is associated with the loan, ignoring any possible changes that might be expected to occur in the purchasing power of money. What do I mean by that? I want to contrast that with a concept known as the real interest rate. Now, the real interest rate is usually not reported in the financial press. It's not what's going to be quoted to you when you go into a bank and ask for a loan. It's probably not what Jill and Jack have been discussing when they negotiated the terms of this particular loan. But in macroeconomics, it's the real interest rate rather than the nominal interest rate that actually matters for decision making. The real interest rate takes into account any expected changes in the purchasing power of money that might occur over the life of the loan. It's taking into account, if you like, the rate of price inflation that is anticipated over the life of the loan. And that's going to make a big difference. And I'm going to use lowercase r to represent the real interest rate. Let me repeat, it's the real interest rate that matters for decisions about borrowing and lending. Let me just explore that for you. Suppose the expected inflation rate over the coming year is 5%. It doesn't matter how that expectation is formed. For whatever reason, Jack and Jill anticipate that over the coming year, the rate of inflation is going to be 5%. So the real purchasing power of any given amount of money is going to be eroded by 5% over the course of the year, simply because the general level of prices in the economy is going to increase by 5% over the course of the year. What does that do to this calculation? Well, the nominal interest rate is unchanged. Remember, the nominal interest rate is simply a comparison of that end of year payment with the size of the loan. The nominal interest rate is still 5%. What about the real interest rate? What has Jill, for example, really gotten as a result of this transaction? Well, Jill started out with $100. She ends up at the end of the year being repaid $105. Over the course of that year, if this expectation comes to pass, the general level of prices in the economy has increased by $5. So the real purchasing power of any given amount of money has been diminished by 5%. In real terms, therefore, Jill is no better off. She had $100 of real purchasing power at the beginning of the year. She's ended the year with $105, but the real purchasing power of that $105 is no different to the real purchasing power of the $100 at the start of the year. In real terms, Jill has gained nothing. The real interest rate on this transaction is 0. So should Jill lend to Jack? Well, maybe not, because there is nothing in a real sense that Jill can gain from this loan. And that's the sense in which it's the real interest rate that actually influences decisions about borrowing and lending, not the more commonly quoted nominal interest rate. And in macroeconomics, therefore, we focus on the real interest rate as being the determinant of borrowing and lending decisions. If we're thinking about planned investment, it's the real interest rate that influences planned investment. So just a quick note on this. We're going to come back and use this finding in later lectures, so it's probably not a bad point to just clarify things. There is a formula that links all of these three terms, the real interest rate, the nominal interest rate. Now, it's a convention in macroeconomics to use the Greek letter pi to represent the inflation rate, and pi with an E there represents the expected inflation rate. So any introductory book on finance, for example, will have this formula in there. It just shows the formal link that exists between the nominal interest rate, capital R, the real interest rate, lowercase r, and the expected rate of inflation pi e. A little bit cumbersome to work with that formula, so you can play around with it a little bit. I won't do this in any great detail because it's not all that important for our purposes, but if we multiply both sides by the denominator, 1 plus pi e, and that must equal 1 plus r. If we expand the left-hand side out, we'll end up with 1 plus pi e plus r times pi e equals 1 plus r. Subtract 1 from both sides, and this expression here is usually very small. You're usually multiplying two very small numbers in that case, so let's, just for convenience sake, call that equal to 0. What you're left with, if you rearrange it, is that expression there, and that's the one we'll work with, that the economy's real interest rate is equivalent to the nominal interest rate minus the expected rate of inflation. That's a very famous equation in economics, and you'll often come across this term. It's called the Fisher equation, after a very famous American economist, Irving Fisher, who first thought seriously about these issues and realised this important distinction between the real and the nominal interest rate. For our purposes, though, what I want to highlight is that it's the real interest rate that influences planned investment decisions. So when I talk about the link between interest rates and planned investment, it's actually a link between the real interest rate and planned investment. I'm going to come back and explore these issues about interest rates and the economy in a subsequent lecture. But let's just continue on how monetary policy fits into the basic Keynesian model. So we've seen how fiscal policy can be used to try to counteract a contractionary output gap. We've talked about some of the problems with that. Let's suppose those problems are of sufficient concern that fiscal policy is ruled out as an option and instead monetary policy is turned to, or, as we've seen in the global financial crisis, the problem is so large that it's thought that neither fiscal nor monetary policy alone can address the problem, but you need both of them. But let's focus now on monetary policy. In this basic Keynesian framework, it actually doesn't look all that different from fiscal policy. What we're trying to do is to boost planned aggregate expenditure in the economy, to eliminate the contractionary output gap. But with monetary policy, what we're going to do is focus on providing incentives for firms to boost their planned investment. And we can do that through the mechanism of providing firms with lower real interest rates through monetary policy. So if that's the level of planned injections associated with a real interest rate of 5%, then the role for monetary policy is perhaps to cut the real interest rate to 2%, in doing so providing encouragement for firms to boost their planned investment, shifting the planned investment line upwards and restoring equilibrium at potential GDP. So that's the monetary policy approach to trying to address a contractionary output gap.